Good afternoon, students. In last lecture, we have discussed about the electricity power generation in India. In this lecture, we have to discuss about the energy efficient electric motors. Yeah, right. There are direct current synchronous motors. Right. We have to discuss these types of motor in this lecture. So, first of all, electric motors. Here, motors converts electrical energy into mechanical energy by the interaction between the magnetic field that is set up in the stator and rotor. Industrial electric motors can be broadly classified as induction motor, direct current motors, synchronous motor. All motor types have the same four operating components: stator, right, rotor, rotating winding, etc. Then motor types. First motor is electric motor. Induction motor. So first type is induction motor. See here, induction motors are the most commonly used prime mover for various equipments in industrial applications. In industry, induction motors, the induced magnetic field of the stator winding induces a current in the rotor. This induced rotor current produces a second magnetic field which tries to oppose the stator magnetic field, and this causes the rotor to rotate. The three-phase squirrel cage motor is the workhorse of industry. It is rugged and reliable, and is by far the most common motor type used in the industry. These motors drives pumps, blowers and fans, compressor, conveyors and production lines. The three-phase induction motors has three windings, each connected to the separate phase of the power supply. Right. Then second, induction motor is very applicable in industries and for varying purpose. Right. Next, we have to discuss direct current motor, that is DC motor. See here, in the direct current motor, as the name implies, this is used for a direct current direct unidirectional current. Direct current motors are used in special applications where high torque starting or where smooth acceleration over broad speed range is required. Right. Third motor is synchronous motor. See here, in the synchronous motors, AC power is fed to the stator of the synchronous motor. The rotor is fed by DC from a separate source. The rotor magnetic field locks onto the stator rotating magnetic field and rotates at the same speed. The speed of the rotor is a functioning of the supply frequency and the number of magnetic poles in the stator. While induction motors rotate with sleep, that is RPM, is the less than the synchronous speed. The synchronous motor rotate with no slip, that is the RPM, is the same as the synchronous speed governed by the supply frequency and number of poles. The slip energy is provided by DC, and this may be called as excitation power. Right, these the three motors are majorly used in industry: induction, direct current, and synchronous motor. See here, we have to discuss again motor characteristics, that is motor speed, power factor, etc. So motor see here, first in this motor speed, the speed of the motor is the number of revolutions in given time frame, typically revolutions per minute, that is called as RPM. The speed of an AC motor depends on the frequency of input power and number of poles for which the motor is wound. So the synchronous speed in RPM is given by the equation where the frequency is in hertz or cycles per second. So synchronous speed, that is RPM, which is equals to 120 into frequency divided by number of poles. This will calculate the synchronous motor speed, that is in RPM. So Indian motors have synchronous speed like 3000 to 1500, 1000, 750, 600, 500, 500, 375 RPM, corresponding to number of poles being 2, 4, 6, 8, 10, 12 and 16. That is always even, and a given main frequency of cycles per second, the actual speed with which the motor operates will less than the synchronous speed. The difference between synchronous and full load speed is called slip and is measured in percent. It is calculated using the equation, that is equation is equals to slip is equal in percent, which is equals to synchronous speed minus full load rated speed divided by synchronous speed into 100. Right, this is the slip percentage. As per relation stated above, in this equation, the speed of AC motor is determined by the number of motor poles and by the input frequency. It can also be the seen that theoretical speed of AC motor can be varied infinitely by changing the frequency. By the manufacturer's guidelines should be referred for the practical limits to speed variation. With the addition of variable frequency drive, the speed of motor can be decreased as well as increase. Right? Power factor. The power factor, next is power factor. See here, the power factor of the motor is given by the formula, that is power factor is equals to cos phi, which is equals to unit of this is kilowatt per kVA. This is all about the power factor. As the load load on the motor comes down, the magnitude of the active current reduces. However, there is no corresponding reduction in the magnetizing current, which is proportional to the supply voltage with the result. So that the motor power factor reduces with reduction in applied load. Induction motors, especially those operating below their rated capacity, are the main reason for low power factor in the electric system. Next, motor efficiency. This is also very important characteristics, that is motor efficiency. AC induction motor efficiency, first in this AC induction motor efficiency that is nu, denoted by, it is the ratio of the mechanical energy delivered at a rotating shaft to the electric energy input, right? What is AC induction motor efficiency? It is defined as the mechanical energy delivered at rotating shaft to the electrical energy at the input. See here, next we have already discussed power factor. It is PF. Motors, like other inductive loads, are characterized by the power factor less than 1. As a result, the total current drawn needed to deliver the same real power is higher than for a load characterized by a higher power factor, right? Next, an important effect of operating with a power factor less than 1 is that resistance losses in wiring upstream of the motor will be higher, since these are proportional to the square of the current. Thus, both high value of nu and power factor close to unity are desired for efficient overall operation in the plant. Squirrel cage motors are normally more efficient than the slip ring motors, and high speed motors are normally more efficient than the lower speed motors. Efficiency is a function of 120 into frequency synchronous speed. RPM is equals to number of poles. Kilowatt power factor is cos phi. It is kVA. Synchronous speed full load rated slip is equals to 100 synchronous speed motor temperature. Totally enclosed these are the fan cooled or more efficient screen protected drip proof motors, right? The next point is motor selection. Few of silent selections issues are we have to discuss in this motor selection. In selection process, the power drawn at 75% of loading can be meaningful indicator of energy efficiency. Next, reactive power drawn by the motor. Next, Indian standard 325 for standard motors allows 15% tolerance on efficiency for motors up to 50 kilowatt rating, and 10% motors over 50 kilowatt rating. The Indian standard IS 8789 addresses technical performance of standard motors, while IS Indian standard 12615 right here, Indian standard 8789 and Indian standard 12615 address the efficiency criteria of high efficiency motors. Both follows IEC 34-2 test methodology, wherein stray losses are assumed as 0.5% of input power by the IEC test method. The losses are stated, and if one goes by IEEE test methodology, the motor efficiency value would be further lowered. It would be prudent for buyers to procure motors based on the test certificates rather than the labeled values. The energy saving by motor replacement can be worked out by the simple relation in kilowatt saving is equals to in kilowatt output into 1 by new old minus 1 by new, where new old and new are the existing and proposed motor efficiency values. Next, the cost benefits can be worked out on the basis of premium required for high efficiency versus worth of annual saving. So this is all about the motor selection. Right, in this we have discussed about the AC induction motor efficiency, right, motor selection. In this we have to select there are few Indian standards, and we can select the motor with respect to this Indian standard. It will be easy to purchase a motor without checking, right. We can purchase with label, right. So this is because of Indian standards. And we have discussed types of method, motors, induction, direct, synchronous mode, right. The construction of this and motor characteristic, speed, power factor, we have discussed these characteristics also. If you have any doubt, please ask me anytime. You can call me. In next lecture we we are going to discuss energy efficient motors, energy efficient motors, right. So we stop here. We'll meet in next lecture. Thank you.